this video, it will refresh us and then come back again.
Hi, I'm Rob. Welcome to Math Antics. In the last two algebra videos, we learned how to solve simple equations that had only one arithmetic operation in them. But often, equations have many different operations, which makes solving them a little more complicated. In this video, we're going to learn how to solve equations that have just two math operations in them, one addition or subtraction and one multiplication or division. And the concepts you learn in this video will help you solve even more complicated equations in the future. Now, as you might expect, equations that have two arithmetic operations in them are going to require two different steps to solve them. In other words, to get the unknown all by itself, you'll need to undo two operations. But that doesn't sound too hard, right? I mean, we learned how to undo any arithmetic operation in the last two videos. And that's true, but there's a couple reasons that make two-step equations a little trickier to solve. The first is that there's a lot more possible combinations of those two operations. And the second is that when there's more than one operation, you have to decide what order to undo those operations in. Hello? If you need to know what order to do operations in, just follow the order of operations rules. You did watch that video, didn't you? I sure did. But the order of operations rules tells us what order to do operations, not what order to undo them. Oh, well, then could we reverse the order since we're undoing the operations? Now that's a good idea. Well, of course it is. When solving multi-step equations, that's basically what we're going to do. Using the order of operations rules in reverse can help us know what order to undo operations in. But it can be a little tricky actually putting it into practice. So, to see how it works, let's start by solving a very simple two-step equation. 2x plus 2 equals 8. In this equation, the unknown value, x, is involved in two different operations, addition and multiplication, which is implied between the first two and the x. And to undo those two operations, we need to use their inverse operations, subtraction and division. But the question is, which one should we do first? Like many things in life, the order we decide to do things in can make a big difference. Oh, come on! There's gotta be an easier way! First socks, then shoes. Fortunately, in math, we have a special set of rules that tell us what order to do operations in. Those rules tell us to do operations inside parentheses or other groups first, and then we do exponents, and then we do multiplication and division, and last of all, we do addition and subtraction. Those are the rules you need to follow when simplifying mathematical expressions or equations. But solving an equation is different because we're trying to undo any operations that the unknown value is involved with so that the unknown value will be all by itself. So when solving equations, the best strategy is to apply those order of operations rules in reverse. Using the reverse order of operations is not the only way to solve a multi-step equation, but it's usually the easiest way. Just like it's much easier to take your shoes and socks off in the reverse order that you put them on. Are you sure it's socks before shoes? Since the order of operations rules tell us to do multiplication before we do addition, we should undo addition before we undo multiplication. So first, we undo the addition by subtracting 2 from both sides of the equation. On the first side, the plus 2 and the minus 2 cancel each other out, leaving just 2x on that side. And on the other side, we have 8 minus 2, which is 6. Next, we can undo the multiplication by dividing both sides of the equation by 2. On the first side, the 2's cancel, leaving x all by itself. And on the other side, we have 6 divided by 2, which is just 3. There, we've solved the equation using the order of operations rules in reverse. And now we know that x equals 3. That wasn't so bad, was it? Let's try solving another simple two-step equation that has division and subtraction in it. X over 2 minus 1 equals 4. Again, we're going to apply the order of operations rules in reverse to undo the subtraction and the division operations. Since we would normally do the subtraction last, we're going to undo it first. To undo the subtraction, we add 1 to both sides of the equation. On the first side, the -1 and the +1 cancel out, leaving just x over 2 on that side. And on the other side, we have 4 plus 1, which is 5. And then, to undo the divided by 2, we need to multiply both sides by 2. On the first side, the 2's cancel, leaving x all by itself. And on the other side, we have 2 times 5, which is 10. So our answer is x equals 10. Those examples are pretty easy, right? But solving two-step equations gets a bit trickier thanks to a little something in math called groups. Do you remember how parentheses are used to group things in math? And our order of operations rules say that we're supposed to do any operations that are inside parentheses first. In other words, we need to do operations that are inside of groups first. Well, guess what? That means that when we're solving equations and undoing operations, we need to wait to do groups last of all. To see what I mean, let's solve this equation, which looks very similar to the first one we solved. The only difference is that a set of parentheses has been used to group this x plus 2 together. And even though that might not seem like much of a change, it makes a big difference for our answer. That's because in the original equation, this first 2 is only being multiplied by the x. But in the new equation, it's being multiplied by the entire quantity or group x plus 2. And that's going to change how we solve it. We're still going to follow our order of operations rules in reverse, but now that the x plus 2 is inside parentheses, which means that it's part of a group, we're going to undo that operation last. Since we're supposed to do operations in groups first, it means that we're going to undo operations in groups last. So in this problem, we should start by undoing the multiplication that's implied between the 2 and the group x plus 2. To do that, we divide both sides of the equation by 2. On the first side, the 2 on the top and the 2 on the bottom cancel, leaving the group x plus 2 on that side. And on the other side, we have 8 divided by 2, which is 4. That looks simpler already, and we can make it even simpler than that, because now that there's nothing else on that side of the equal sign with the group x plus 2, we really don't even need the parentheses anymore. Next, we just need to subtract 2 from both sides. On the first side, the plus 2 and the minus 2 cancel out, leaving x all by itself. And on the other side, we have 4 minus 2, which is 2. So for this equation, x equals 2. And now you can see how grouping operations differently in our equation results in different answers. Let's try one more important example. Do you remember the second equation we solved? X over 2 minus 1 equals 4. In this equation, the 1 is being subtracted from the entire x over 2 term. But take a look at this slightly different equation. This looks a lot like the original equation, but now that the 1 is up on top of the fraction line, it's only being subtracted from the x and not the 2. The x minus 1 on top forms a group. Hold on, how can x minus 1 be a group? I don't see any parentheses or brackets around them. That's a good question. In algebra, the fraction line is used as a way to automatically group things that are above it or things that are below it. For example, in this fancy algebraic expression, everything that's on top of the fraction line forms a group, and everything on the bottom of the line forms another group. Of course, we could put parentheses there if we wanted to make it really clear, but it's not required. Grouping above and below a fraction line is just implied in algebra. Getting back to our new problem, now that we know that the x minus 1 on the top of the fraction line is an implied group, as we learned in our last example, we're going to wait and undo the operation inside that group last. So the first step is to undo the divided by 2 by multiplying both sides of the equation by 2. On the first side, the 2 on the top and the 2 on the bottom will cancel out, leaving just our implied group x minus 1 on that side. And on the other side, we have 4 times 2, which is 8. Next, we can undo the operation inside the group by adding 1 to both sides. On the first side, the minus 1 and the plus 1 cancel, leaving x all by itself. And on the other side, we have 8 plus 1, which is 9. So in this equation, x equals 9. All right, as you can see, solving two-step equations is definitely more complicated than single-step equations, because there's so many different combinations and different ways to group things. But if you just take things one step at a time and remember to undo operations using the reverse order of operation rules, it will be much easier. Just pay close attention to how things are grouped in an equation, and be on the lookout for those implied groups on the top and bottom of a fraction line. And because there are so many variations of these two-step equations, it's really important to practice by trying to solve lots of different problems. As always, thanks for watching Mathantics, and I'll see you next time. Learn more at mathantics.com.
After coming back, let's start solving our exercise. Our first part here to solve the equations from 1 to 6. Let's start to solve it. Question 1 here, we have 7d minus 12 plus 2d plus 3 equals 18. What we will do here, we will take the like terms together. We will combine the like terms. Where is the like terms that we have here? We have 7d and 2d. Okay? 7d and 2d, it's 9d. And we have negative 12 and positive 3. Negative 12 and positive 3, it will be negative 9. And all of this will equal 18. 9d, negative 9 equals 18. Now it came to be a normal equation and small equation as we talked before. 9d minus 9 equals 18. What we will do with the 9 first? What is the relation between 9 and d? It's subtract or minus, so we will add. We will add 9 in both sides. So here 9d and negative 9, positive 9 will be 0, equals 18 plus 9. This will be 9d equals 27. Now what is the relation between 9 and d? It's multiplication. So we will divide 9 in both sides. It will be d equals 3. Question 3. We have 10e, negative 2e, negative 9 equals 39. It's long equation, so we want to combine the like terms. We have here 10e and negative e are like terms. 10 negative 2 is 8e. Negative 9 equals 39. So 8e negative 9 will equal 39. Now it's normal equation. First, we will add 9 both sides. Okay, so the result will be 8e equals 48. 39 plus 9. Then, the second step, what we will do, we will divide 8, because here the 8, it multiplies with e, so we will divide 8 in both sides. So, only e will equal 6. Let's go to question 5. We have 5h plus 6 plus 8h negative 3h equals 76. First, combine the same terms. Where is the same terms? Where is the same terms here? We have 5h, we have 8h, we have negative 3h. Combine them together. 5 plus 8, 13. Negative 3, it's 10. 10h and plus 6, it's same, because we don't have any other terms same to 6, so 6 will be same. 10h plus 6 equals 76. Then we will do as normal. Here, plus or positive 6, we will subtract 6 from both sides. And then we will have 10h equals 76 minus 6, 70. And divide 10 in both sides, because the relation between 10 and h is multiplication, so we will divide 10 in both sides. At the end will be h equals 70 divided 10 will be 7. Let's go to the other questions. Question 2. 3y plus 4y plus 6 equals 20. So combine the same terms, 3 and 4. 3y and 4y are like terms because y here is same term. 3 and 4 is 7. 7y plus 6 equals 20. We will do same. Subtract 6 from both sides. So 7y will be same here. Okay. And 6 will go out with this 6. Then we will have 20 minus 6 is 14. Now we will divide 7 in both sides, because the relation between 7 and y is multiplication, so we will undo it by division. Divide 7 both sides will be 7 equals 14 divided 7 is 2. Next question, question 4. Next question, question 4. We have 4c negative 5 plus 14c equals 67. We will take the like terms here, 14c and 4c. Add them together. 4 and 14 is 18c. Then negative 5, no other terms like the 5, so it will be 18c negative 5 equals 67. Then we have here, what is the sign of the 5 is negative, so we will add 5 in both sides. 18c will equal 67 plus 5 is 72. Then what is the relation of 18 and c? It's multiplication, so we will divide 18 in both sides. So only c will equal 72 divided 18 will be 4. Question 6. We have here 7x minus 2x plus 3 equals negative 32. First take the like terms here, negative 2 and 7x. 7 negative 2 equals 5x. 5x plus 3 equals negative 32. So 5x plus 3 equals negative 32. Then we will subtract 3 from both sides, okay? Let's subtract 3 from both sides. We have here positive 3 and negative 3 equals 0, خلاص. Okay? Then we have negative 32 and negative 3. Negative 32, we have here negative and here negative. What we will do with the negative? Negative 32 and negative 3. Both sides mean we will add with the same sign. Both sides we will add with the same sign. Negative and negative means that we will add with the same sign. So we will be 30, negative 35. Okay, you understand how we got this sign? Then we will divide 5 in both sides. And at the end, the result will be x equals negative 7, because negative 35 divided positive 5 will be negative 7. Is that clear for now? Let's take the other part from the questions. Start from question 7. We have different way to answer. Here we have 4x over 13 plus 3x. We have 4x over 13 plus 3 over 13 equals negative 1 over 13. What we will do here? We have 13 in all sides. We have divided in all sides. If we work as we are, it will take a long time from us to work with it, okay? So we have another way. We say it before in the lesson that we can, if we multiply with the denominator or with the number down, it will be remove the fraction, okay? So when I multiply, what is the number down in all the sides here, in all the terms? What is the number down? All the terms has 13 down. So if I remove the 13 down, what I will have? I will have normal equations I can solve, right? So how can I remove the 13 down? I can remove it, it's a divide. So I can remove it by multiplies. So I will multiply 13 in all terms. All the terms I will multiply it with 13. Okay, so I will multiply 13 with all terms. 13 multiplies 4x over 13 and 13 multiplies 3 over 13, and 13 multiplies 1 over 13. Don't forget to multiply all the terms, even the one after the equal sign. So 13 will be multiplied 4x over 13, and 13 will be multiplied with 3 over 13, and 13 will be multiplied with 1 over 13. Okay, when we multiply here, what we will do? Can we simplify? You remember simplifying fraction? So this 13 will go out with this 13. This 13 will go out with this 13. This 13 will go out with this 13. So what's remaining from first term, what will be remaining will be 4x. And from the second term, 3. And from the other term is negative 1. I'm multiplying 13 with all, so we will have 4x plus 3 equals negative 1. Now it came for me as normal equation as we solving before, okay? So we have 4x plus 3 equals negative 1. What we will do? We will subtract 3 from both sides. From both sides of the equals, not from both terms, from both sides of the equals. So 4x will equals negative 4, negative 1, and negative 3, it's negative 4. Then we will divide 4 in both sides. So here, x will equals negative 4 divided 4 is negative 1. X is equals negative 1. Let's take question 9. What we have in question 9 here? We have 4 over 5 minus 2p over 5 equals 6 over 5. So what is the number down all? It's 5. So let's multiply 5 in all sides. Let's multiply 5 in all sides. So it will be 5 multiplies 4 over 5. And 5 multiplies 2p over 5. And 5 multiplies 6 over 5. So what I will do, what I did here, I multiplies 5 in all terms. I multiplies 5 in all terms, not in the both sides, in all terms. From here, 5 will go out with 5, 5 here will go out with 5, 5 will go out with 5, because we are simplifying fraction. So from this part we have 4 remaining, here we have 2p remaining, here we have 6 remaining. So we will have here the remaining is 4 and negative. Don't forget we have here negative, we put it down, don't forget that. 2p equals 6. We will work as normal. Take out 4. How we will remove 4? We will, 4 here, what is the sign of 4? It's positive, so we will subtract 4 from both sides. So negative 2p will equals 6 minus 4 is 2. Then we will divide by negative 2 in both sides. Negative 2 divided negative 2, it's 1, equals positive 2 divided negative 2, it's negative 1. So p will equals negative 1. Let's check our next question, question 8. Y over 2 minus 5y over 6 plus 1 over 3 equals 1 over 2. What we should do here? Here we don't have the same number down. We have here 2, and here 6, and here 3, and here 2. What we will do now? How we will do it? We will take the greatest common factor. If you can remember, what is the greatest common factor? It's a factor can be multiplied by all the numbers, or a number, it's a factor for all the numbers, okay? And this is the biggest factor. Maybe you cannot remember what is the greatest common factor, okay? So we will find a number can be divided by all the numbers. Of course, it will be 6. 6 I can divide it by 2, divided by 3, divided by 2, and I will have one number. It will not be fraction. I can simplify with it. So in question 8, I will multiply all the terms by 6. I will multiply all the terms by 6. So here, first one, 6 multiplies y over 2, and 6 multiplies 5y over 6, and 6 multiplies 1 over 3, and 6 multiplies 1 over 2, and 6 multiplies 1 over 2. So I multiplies all the sides by 6. Let's simplify each one. Let's simplify each one. Okay? I will simplify the first one. First one here, 6 with 2. 6 divided 2 is 3. And 6 with 6 is 1. 6 with 3, 6 divided 3 is 2. And 6 with 2 is 3. So what I will do with this, the numbers, after simplifying like this, or dividing the 6 with the number down, I need to multiply the numbers here inside the brackets. I will multiply the numbers inside. Okay? So 3 multiplies y, it will be 3y. 1 multiplies 5, it will be 5y. 2 multiplies 1, it's 2. 3 multiplies 1 is 3. So I will have 3y. We have here negative. Don't forget the negative. 5y plus 2 equals 3. Now it's normal equation. We can solve it together. 3y equals 5y plus 2 equals 3. It's normal. First, we need to combine the like terms. Where is the like terms? 3y and negative 5y. 3 and negative, positive 3 and negative y will be negative 2y plus 2 equals 3. Remove the 2 by subtracting 2 from both sides. Then I will have negative 2 equals 1. Then we have here 2 multiplies y. So we will inverse it or undo it by divided 2. Divided negative 2 in both sides. Negative 1 over 2. Don't forget, it's 1 divided 2. It's 1 over 2. Let's go to question 10. We have 15 over 8 z plus 1 over 3. 15 over 8 z plus 1 over 4 equals 4. What we will do? We need to multiply by number, can take out the denominator from all the terms. So it will be easy for us to solve. If I multiply by 8, or the big number here is 8, so if I multiply by 8 in all terms, it will be easy. Okay, let's see. So I will multiply by 8. 8 multiplies 15 over 8 z, and 8 multiplies 1 over 4, and 8 multiplies 4, and 8 multiplies 1 over 4, and 8 multiplies 4. So I multiply 8 in all sides. Then what we will do here, let's simplify. 8 will go out with 8 and we will have 1. 8 divided 8 is 1. 8 divided 4 is 2. And then here this 4 is over 1. So 8 divided 1 is 8. Is that correct? Then we will multiply. 1 multiplies, we will multiply. 1 multiplies 15, 2 multiplies 1, and 8 multiplies 4. So it will be 1 multiplies 15 is 15z, and 2 multiplies 1 is 2, and 8 multiplies 4 is 32. Then subtract 2 from both sides. You have 15z equal 30, and then divide it by 15 in both sides. As a result, z will equal 30 over 15 will be 2, or 30 divided 15, it will be 2. So here z will equal 2. At the end, complete solving your book, page 590, from question 12 to question 22.